Hi, I am Wei-Cheng Tseng. I am going to present our work. Speech quality assessment is an important part of speech processing to measure the system performance. Mean opinion score, or MOS, is one of the most common ways for subjective evaluation. MOS correlates well to human perception. However, it involves intensive crowd work and is time-consuming. Several machine learning approaches were thus proposed for automatic assessment. Here we present the first use of self-supervised pre-trained models for MOS prediction. Self-supervised learning is a branch of unsupervised learning where data provides the supervision. It tasks the network by predicting the withholding part of the input. And the network is forced to learn meaningful representations to solve the task. Self-supervised models pre-trained on large-scale datasets can benefit many downstream tasks, such as ASR. Here we show that they are also useful for MOS predictions. Here is the proposed framework. Given an utterance, we first divide it into several segments. Then the self-supervised model extracts the frame-level representations of each segment. A downstream module then predicts the mean score from these representations. Besides, we also predict the individual judges' scores for better exploitation of the dataset. And will be discussed in the detailed session. During the inference, only the mean score is predicted since we are interested in the average score rather than individual judge scores. In the downstream module, an attention pooling first computes the segment-level representations by aggregating frame-level representations. Then we projected them to segment-level scores and clipped to the range of 1 to 5. Finally, we can determine the mean score by averaging these scores. The bias score follows the same procedure. We fine-tuned several self-supervised pre-trained models with the proposed framework on VCC 2018 dataset. And we only show utterance and system-level performance of WAVE to VEC2 and Terra for simplicity. The baseline model, MB-net, is included for comparison. We measure the mean squared error to find how close the predicted score is to the true score. The result shows that our models can predict more accurate scores compared to the baseline. We also measure the linear correlation and rank order correlation to see how well the models distinguish utterances of different qualities. In terms of utterance level, our predictions correlate better to the ground truth. As for system level, our models give competitive performance. Overall, our models work better than the baseline. To give a brief summary, we proposed an automatic MOS predictor which incorporates self-supervised learning. The experiment results showed that our models achieved the best or competitive results compared to the previous state of the art. This is the end of my highlight.